Hello, everyone. Welcome to another episode of Fabric Tech Talk Fridays. I'm Swetha Mannepalli, your host. Today, I have a very special topic and guest as well. The topic is, see, we all know Microsoft Fabric works on a business. The business model for Microsoft Fabric is basically capacity units, which are directly proportional to SKU. What is the right SKU for the amount of workloads that I'm using? Whether you are getting started with your Fabric journey or you're already using other data products and you want to start looking at Fabric on, how do I get started? Where do I start from a SKU or estimation perspective? So we'll be going deep into that particular topic. And I have here Andreas and Chris, who are the brains behind the capacity estimator tool that we have today. Before we get into or dive deep, do you want to introduce yourselves?
Sure. My name is Andreas Bergstedt. I work for the global black belt team for Azure.
Hi everyone, my name is Christopher Maneu and I'm a cloud advocate in Azure Data.
Okay, before we dive deep into all the technicalities, I want to sort of take a step back and ask you guys, why is it important? Where would the whole SKU, when would in the Fabric adoption journey, when would customers start thinking about, okay, wait a minute, what is the right SKU? Am I looking at? What is that point?
So, in the beginning, obviously. So, let's say you're a CDO and you're planning out your next project and you're looking at how you can get business engaged in data literacy. And obviously, when you're starting a project, it's important to get a budget going. You need to understand what you have to request financial approval for. So, if we don't know capacity, it's going to be really difficult to understand what the costs implicated are going to be as well.
Yeah, and even for an engineer, like in the Azure world, if you're a software engineer, you should be concerned about cost because maybe some line of code you're doing will impact the cost of your solution greatly. So as an engineer, as a data engineer, I want to understand what is the cost structure, just having a rough idea. So even if as an engineer, not from a business perspective, I need to understand a few things.
I really like how you guys put together both from a BDM perspective as well as a TDM perspective on why capacity estimation is really important for both sides of the house. So if you are really starting from a development journey, you really want to know, what am I provisioning for? How much the consumption is going to look like. Because by the end of the day, you don't want to spin up a project, end up with a huge bill to be answerable for your management. And of course, from a CDO or business deliverable perspective, you really want to know, what am I getting myself into when it comes to pricing and budgeting. And you really want to plan that before you get into planning your data project, which is what eventually will happen anyway. So with that, what I would love for us to uncover in this episode, Andreas and Chris, is let's start from a greenfield. One of the things that I want to talk about is, let's say I'm a customer and I'm starting my Fabric journey and I have no idea about this SKU estimator or what is the capacity, which workloads consume what, how do I really go about looking at these? So I want to start with that. So again, reiterating my question, I'm new to Fabric from a customer perspective, and I want to look at data integration, data warehouse, RTI. There's so many workloads within Fabric. If you want to take scenarios on, hey, this is the data size that I'm looking at, and I'm looking at using, let's say, Spark, data warehouse, RTI, and I also want to throw in Power BI users that will be consuming these reports. Can you give us the end-to-end of what it looks like from a SKU estimation perspective?
Sure. So you open up a web browser and you go to aka.ms/Fabric SKU Estimator.
That's as simple as that.
As simple as that.
Perfect.
And then we have some input. So we have our total data size compressed. So this is something you would look at if you have an on-prem data warehouse. You're running some analytical workloads. You can always assume that data is compressed on size or on disk. So whatever that data state looks like, and you take your entire environment into consideration. So your integration layer, your staging layer, and your final data product and data dimensional model and data warehouse layer. So in this use case, let's say we have 10 terabytes of data. We're on a single batch cycle, meaning that every day we run one big process of data, right, end to end.
Okay.
And then as far as number of source tables across all data sources, So this is, you can think of this from like your pipelines that you're executing. So you have your general ledger, your customer tables, address tables, etc., whatever it would be, right? So in this case, we have 500 of those.
That sounds reasonable. For a
But-
medium scale data project, sounds reasonable.
Cool. So then we select workloads. So we have data factory because we need to think about our integration pipelines, like how we acquire data. And then data warehousing because we want to be able to ingest, process data, and eventually be able to serve it up somewhere, right? Once we selected these workloads, there might be some additional data that we need to input. So on the data factory side, if you're running Dataflow Gen 2, you can put in some inputs here around how often you run them, and the model will calculate that. But for this use case, we'll put in a 0 just to make sure we don't run it.
So what does that mean? Chris, I know you added 0 as the input for ETL operations. So once you ingest the data, where are we doing the ETL manipulations before it gets to the data warehouse?
So the data warehouse or this model
Warehouse layer.
will assume that you're going to run copy into jobs into staging tables and then process up dimensions and fact tables.
Sounds
So hence why the data warehouse is built out to do all of your transformation.
makes sense.
Cool. Right. So we put 0 in there, and let's hit calculate and let's see what results we get. So as soon as we hit calculate, we're now sitting on an F256, and we can see that the data factory is roughly about a percentage of the workload. 58% is our data warehouse processing.
So do you want to talk a little bit about the percentage, Chris? Why are we seeing those percentages? What does it really mean from a skew, level?
Sure. So what we try to estimate is the consumption that you need to run your workflow, your architecture. But that doesn't mean that you will actually deploy one capacity for all of that. You may want to segregate your capacities depending on different business SLAs, for example. Let's take a graph so you can talk about this a little bit more. In this schema, we have like a modern data warehouse architecture where obviously you have the ingestion with data factory, you have the main data warehouse process. So that is like the most important thing. Like processes need to be run daily and they need to run, like it need to work, even if people are busy doing things, because that's your production data. The reports, you may have like uneven usage of reports. Maybe people doing reports mostly only in the morning and no reports run on the weekend, etc. So you may want to optimize that part of the usage and maybe reduce the capacity over the weekend or even like stop the capacity. And then you may have like some exploratory work, especially in data science, where it's kind of a best effort. You want to provide like best effort capacity to your team, but if they need more capacity, you prefer to shut them down instead of having a risk of having issue in production.
Understood.
And the fact is, what the SQ estimator gives you in that case is F260 256 for the entire system. So you can go back to the percentages and say, okay, my data warehouse is this percent and my data factory is this percent. So maybe I can create two capacitors with a total amount of 256.
Understood.
And the percentage give you an idea of how you can split them based on consumption needs.
So that's really important to look at what are not only the workloads that you're using, but where those workloads are taking the more capacity, and depending on that, one of the best practices. Perfect. So yeah, any other scenarios that you want to run through, Andreas?
Sure. Let's add some Power BI. Since we're here and Power BI is everywhere, right?
Yes.
So once we add Power BI as a workload, we obviously need to give some inputs. So let's say we have 500 daily Power BI users. Oops. And we have maybe 25 Power BI report writers and developers. And since we've been migrating from a known OLAP model, we know that our max data model size is 25 gigabytes. Let's just add that too.
All right, 500,
25 and 25.
and we knew the probe model size. Yeah.
Yep. Right.
Cool. Still on the same capacity. Don't need to upgrade.
That is good.
That's nice.
Nice.
But I want to touch on the migration, because you talked about migration, Andreas. This is top of mind for our customers. If they already have, data warehouse, let's take Synapse Gen 2, for example. So if they already have their data estate built with Synapse Gen 2, and now they want to make their way into Fabric Data Warehouse, would you like to walk us through that scenario on how those customers can figure out, oh, if I'm on, let's say, DW1000C, how does it translate to what capacity am I going to look at in Fabric Data Warehouse?
Sure. So we have some pre-cooked scenarios where we've looked at telemetry and what approximately this will turn out to be. So you have a migration assistant, and then you can select your SKU. So if you maybe if you select the 1500 data warehouse units, or let's say you running Synapse dedicated pool, and you hit calculate again, and that's going to update your estimation. Now, you can see here that our model has changed. So we've gone from a 256 to 128, but it's based on what we see with telemetry for that specific Synapse instance. So it does change the model a bit, and some of the results you get may vary with your experience, but that's why we have metrics app, so we can lab this out.
So what other workloads do you have? Do you have databases? Because I know that's also something that we introduced recently last year. So do you have RTA workloads? If I'm bringing streaming data, so do you cover this capacity estimator covers all of that?
It does. Let's take a common use case, so cloud operations use case. So typical thing, we're running a business is running maybe 500 container applications. And they want to monitor their telemetry. We're going to need something to process the streaming data set. So we have event stream, right? And event stream is all based on, you get data in, it streams, and we push it down somewhere. So if we have 500 container applications and they are running, the telemetry every 5 seconds or so, then that's an average payload size about 2 kilobytes per message. Then that's roughly about 16 gigs of data a day. So if we put that in,
it's interesting. Like you made some calculation. So the input we get in the real-time intelligence should cover all the use cases. But for example, if you're doing IoT work or in this case telemetry work, you may have to do some computation beforehand. That's something we're working on in updates to this SKU estimator to make them easier for you.
Intuitive.
Yeah, but you may have to do some computation from what you're doing to actually get the inputs.
Is this particularly to the event house, event stream workloads?
yeah,
Okay.
yeah. Maybe change that from 16 terabytes to 16 gigs.
Oh.
Sorry, there we go. And obviously in a cloud ops scenario, we're gonna need some real-time analytics. So we're gonna need an event house. And we're gonna need maybe a data activator so we can be a bit proactive with alerts and management, right? So let's think about that from an event stream perspective. So we have now 2 workloads we need to push down. So if you in terms of destinations, if you add 2 push-based destinations for obviously event house and activator.
Activator, yeah.
And that is it for event stream. If we go to event house, we obviously need to take our 16 gigs of data into consideration. And then we say we're going to run short-term retention. It's only 7 days of query cache because we're running, when something goes wrong with our container apps. And then maybe 90 days worth of storage for long-term retention and querying. And then obviously it runs 24 hours a day because we have customers using our applications.
Yeah.
Cool. And then from a data activator perspective, we obviously don't want all our telemetry to go through data activator. So let's say it's about 2 times orders of magnitude less than our 8.6 million messages, so 86,000 messages a day. And maybe we have 5 alert rules that we set up, something to manage critical outages, maybe some Power Automate things that are going to fire off ServiceNow tickets to log incidents or escalations through Teams or emails to notify shift managers, etc. Cool.
So let's run the calculations. Oop. Oh, I forgot to say 0 and 0. Let's run the calculation. And we got an F8 as a result.
Perfect. Sounds good. No, this is really amazing to see how all these things come together, both from whichever workload that you're using within Fabric. Thank you so much for sharing this information with us today. Really appreciate your time.
Oh, my pleasure. Thank you.
Thank you everyone for watching. If you found this video valuable, don't forget to hit that like button.
If this is your first time visiting the Microsoft Fabric YouTube channel, be sure to smash that subscribe button.
Drop a comment below on what you would like to see on the future episodes of Fabric Tech Talk Fridays.
That's it for today. See you all next Friday for another deep dive into Microsoft Fabric.